In this video, we will continue our discussion about the anti-inflammatory function of the engineered antibody, and we will discuss the in vivo validations of these anti-inflammatory functions and how they have engineered their antibodies to have this anti-inflammatory function. It's been discussed in our previous videos. You can refer to that video to understand the concept about these anti-inflammatory functions of the engineered antibody. So they have developed, as we know that in the previous experiment they have developed two different kind of antibodies. One has this B4, one they named as B4FC, and another they named it ST6FC. Both of them has different glycosyltransferase uh, to add different carbohydrate structures that has anti-inflammatory properties. B4FC will add galactose and ST6FC will add sialic acids. So they first they checked their in vivo validations in a mouse where they have introduced this IgG1 auto antibodies that has anti-inflammatory functions in anti-inflammatory response in the mouse, and then they use different kind of reagents to check whether it will give this IgG1 auto antibodies has inflammation response in the mouse. Yeah, this is what I want to say that. And they use different reagents such as PBS, IVIG, B4FC, ST6FC to check the anti-inflammatory response. PBS is the control, and they don't expect any reduction in the inflammations in this. So in the case of PBS, they based on the clinical score, they see that it has the high robust inflammations, and when they use the antibodies individually, these engineered antibodies individually such as B4FC and ST6FC, then they also see that it has the high inflammations, whereas the commercially treatment to cause commercial diagnosis to reduce the inflammation, that is IVIG, cause reduction in the clinical score, indicating that IVIG is cause anti-inflammations in the mouse, that is injected with this IgG1 autoantibodies, and their engineered antibodies does not function well when they are injected individually. However, when both antibodies are introduced simultaneously, both antibodies are introduced in the same mouse simultaneously, they see the reduction in the clinical score, or they see the anti-inflammatory response which is comparable to the response of the IVIG. That can be seen in the panel C, where we can see that when both the antibodies are introduced in the same mouse model, or both the antibodies are co-injected in the same mice models, they see the reduction in the inflammations, and these things are quantified. Panel C is quantified in the panel D, where we can see that the anti-inflammatory response by IVIG and B4ST6FC is comparable, and it's lower than the clinical score of the mice that is injected with this PBS. This indicates that when the engineered antibodies are co-transfected, then it will cause reduction in the inflammations, or we can say that when the galactose and sialic acids both are added to the carbohydrate structures, then there is a less immune response, autoimmune response by the immune system. In the panel E, we can see that in the case of PBS, there is a tissue damage occurs. There is a tissue damage occurs because at the joints, that can be seen by the star mark, because of the autoimmune response. However, there is no tissue damage occurs in the mice that is affected injected with this IVIG or B4ST6FC, indicating that the autoimmune response reduced in the mice, or in vivo reduction in the autoimmune response observed whenever when both the antibodies are co-injected in the mice. After validating their results on this artificial injection of this IgG1 autoantibodies, they want to check whether their antibodies works on some kind of disease or not. So they use this antigen induced mice that has an autoimmune response, and in this case when they use both the PBS and this IVIG and B4ST6FC, they see that reduction in the immune response when n is comparable to the IVIG after 7 days and is statistically lower than the autoimmune response in the mice model that is injected with the PBS, indicating that the IVIG, indicating that this B4ST6FC works well in suppression of the immune response or suppression of the inflammations by changing the carbohydrate structures or by adding galactose and sialic acids one by one. And these results are, and we can see that joint damage because of the autoimmune response can be seen in the case of PBS, that is shown by the star, the HNE staining, and in the trichrome also and PAS also we can see the tissue damage. However, in the IVIG and B4ST6FC injected mice models, this tissue damage are reduced or negligible in this HNE staining or trichrome or PAS staining. And when they check the survival rates of the mice based on this survival rate of the percentage survival rate of the mice that is injected with the different kind of reagent, they can see that in the case of this PBS, the survival rate goes down and it is decreases after 16 to 20 days. However, in the case of IVIG and B4ST6FC, survival rate continues even after the 20 days, indicating that these antibodies or these engineered antibodies works equally well to this IVIG commercially available approach IVIG in diagnosis of the autoimmune diseases such as, and this has been shown here by diagnosing these antigen induced mice. So I hope you understood their in vivo validations of the engineered antibodies that helps in the anti-inflammatory response, which is useful for the autoimmune diseases. If you need to understand more about their experiments in detail, you can go through the reference that has been provided in the description. So that's all for this video. Thank you for your time.